This is going to be my Dew Controller project. I'm just using a Uno at present, but it's going to be a Nano on a board. Have wired here in LCD display 16x2, some LEDs which will be PWM driven associated with each of these two outputs here. 12 volt fuse, of course, RGB LED. There'll be a fan on this side. Put some air vents in to suck some air through. So you can see you've got some things wired here. So we've still got some temperature probe sockets to put here, fan to put here, drill a hole, and then basically next step now is to do this particular Vero board, which the Nano and circuitry will be connected to. And this is an example of the circuit, and what I have to do now is this is 19 holes down by 34 across, so 1, 2, 3, 4, 1, 2, 3, 4, 5. So starting 1, 2, 3, 4 and 5 down, 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 2, 4, 5 down and 4 in. So that hole there has to be where that is. We need to take that off. Alright, so we need to put X in there. So work out where all the X's are going to be on the board. Then I mark them here, and then I'll use a Dremel tool to actually just cut the track. Right, so I've marked all of these that way. And so next step is to take these, cut the tracks either with a hobby knife or Dremel, and then to start mounting the resistors. Right, you can see I've cut the tracks here already. I've got two stereo plugs here, and the sensors have arrived. So now what we're going to do is we're going to connect these up to the 3-pin plugs. The red and the black ground and VCC, they're going to go to the same pins as it were, and the white, which is the signal wire, is going to be soldered to the tip. So we'll do that now. Right, so we have the majority of the components wired on the board, the resistors, the various jumpers, the TIP 120 transistors. Here we have the Nano. Nano is going to fit in like this on the board. So that's sort of what it's going to look like. At the moment we're missing the large diode to provide the reverse voltage protection, and we're missing the header pins, but they should arrive shortly. So they're starting to look pretty good.
Alright, so this is the Dew controller, nearly finished. It's still got the fan wire on, power switches, everything. It's running at the moment. I'm just uploading the software so you can see. It's detected the fact that there are two probes there, and now it's cycling through, getting the temperatures and calculating the dew point and the power, etc. So what we'll do here, because I have the remote version loaded, is we'll load up the Windows software just to show you what it looks like. We'll select COM9, and now we'll restart the board. We'll tell it to go, get this information. We'll tell it to auto update itself. We'll set the fan on, and we'll set the tracking to ambient. Right, so you notice the fan's on. You notice here it's reading the ambient temperature, dew temperature, OTAs, and the relative humidity. These figures are all being shown here. You can display them in Fahrenheit or Celsius. At the moment it's Celsius. We've got various tracking things. We can turn 100% power on, so this one should come up to 100%. Once it sort of cycles through, you can see now it's sitting at 100% power, and that'll be updated on the next refresh cycle. This power here will change to 100%, and we can change channel 2 to 100%. So we'll notice that channel 2 will go to 100%. Yes, it has. And on the next refresh cycle, 10 seconds or thereabouts later, this will update itself to be 100% as well. And of course we can turn the 100% override off, so those switch back to normal. At the moment, 10% power going to those particular G straps. This will again refresh on the next update. There we go, it's sitting at 10%. So we can change the frequency of the update. We can manual update. We can dim the fan LEDs. So this fan LED will go dim. There we go, and so on. So you can see that it's working well. Let me just change the display to Fahrenheit. So on the next refresh cycle coming through, there we go, the figures are now, dew point, etc. are all in Fahrenheit.